All right, Hallie, Megan, we are on your yellow sheet. We're going to add these two columns here, and then we are going to do the review. We'll see how far we get. I don't know. We'll see. Okay. Poisson distribution is a little bit different than binomial because our variables that we have are different. The only two variables that we have are mu and x, which we call r typically. Okay. So it's the number that we want and then the average, like the mean number. Okay. So if there's an average of 8 hurricanes per year and we want to know the chances that this year it has 10, those would be my two numbers that I'm dealing with. Okay. The formula for Poisson is P of X. Again, Poisson and binomial, both of these are finding probabilities. Like, what's the chances of something happening? Carson, you need to be writing this down. P of X is equal to mu to the x power times e to the negative mu. Make sure that's a times, not a minus. All over x factorial. Okay, that is that. That is that. Okay, should we do the hurricanes problem or should we do something else?
I don't know, man.
I like the hurricanes. We'll do tornadoes since Nebraska has tornadoes. Okay, so example. How many tornadoes do we have in Nebraska every year? Example. There were. There's 50 tornadoes in Nebraska every year?
I don't know. Google it.
I'm gonna make it like smaller than that. I'm gonna make it like smaller numbers, just so that we can type numbers smaller. Are you gonna look it up? Are you kidding me? Oh my. Okay. There were 525 tornadoes in Nebraska in the last 10 years. Find the probability that there will be 14 this year. No, not 14. I'm writing wrong. 55 this year.
We should do like finding the probability of a tornado being in Blue Hill.
Oh.
That's a lot of factors.
But that
No,
was
you can just
like,
you can get like the
I do
mileage
actually wanna
that a
know
tornado
that.
travels,
yeah.
and then get the square mileage of Nebraska and then figure it out.
That would be good.
That's
Yeah.
what I think we should do.
Yeah, interesting. Okay. All right. So if you don't know where to start, look at your two variables that you need. We need mu, we need x. Those are the two things that I need. Okay, so if you don't know where to start, we know it's a Poisson distribution and we know those two variables. So all we have to do is from this information, pull out my two variables. All right, mu. Mu is the average. The average is not 525. The average is how much? 525 divided by 10 because it's over 10 years. So they're saying that the average over those 10 years is about 52.5 tornadoes per year, right? Okay. I want to know the chances of how many? 55 happening in a year. Does that sound like a reasonable amount? Like
Yes.
that's a pretty high chance, right?
Yeah.
Okay. 55 is not very far away from the average. What if I said 80 tornadoes in a year?
That's probably a little.
Probably not going to happen. Probably going to be a really low chance of happening. What's the chance? What's the probability if I said like 15 per year or this year?
Probably a little shy.
Probably low also, right? It's going to be somewhere in the ballpark of between 50 and 60 or 45 and 65, something like that maybe, right? Okay. So there is that. Got it? All right, here we go. We need our formula. I'm going to zoom out. So mu is 52.5 to the 55th power times e to the negative 52.5 all over 55 factorial. I hope your calculator lets you do it because those are kind of some big numbers. What's the probability of that happening? It might be like in the ballpark of like,
Syntax error
does it really?
Yeah.
Dang
Hold
it.
because of the, oh wait, hold on. I'm lying.
He's lying.
0.05.
Yeah. 0.05 what?
0.051.
0.051. Oh, that's a lot lower than I thought it was going to be. Yeah, it's not significant. It's barely not significant, right? It's not rare. Not a rare occurrence. It's almost rare. right? It's almost less than 5%, but it's not rare. 5.1%.
That 5.1% represents, is that like P of X?
The probability.
Yes, P of X. That's the probability of having 55 hurricanes this year. Okay. Good, good? 5.1% chance that we had 55 hurricanes this year.
Tornadoes.
That's why you use a pencil.
Not hurricanes. Tornadoes. Yes. Tornadoes. Yes.
No.
Okay. All right. Here we go. This last little row, we've got mean, variance, standard deviation when it applies to poison. Okay. Every single section in 5.1 we did mean, variance, standard deviation. In section 5.2 we did mean, variance, standard deviation. In 5.3 we're doing mean, variance, standard deviation. They are the same thing. They're all the average. They're all the standard deviations. It's just calculating them differently based upon what information you're given, right? So for 5.1, to do the mean, variance, standard deviation with a table was this ugly thing. Do you remember that?
Yeah.
Bleh. This one, mean, variance, standard deviation, a lot nicer formulas, right? This one is even easier than that, right? The mean, to calculate the mean is mu, and the mean is sometimes given to you. But if it's not, it's what you want over the total, not total, what should I say?
Don't want
No.
No.
total.
Retard.
I'll see you.
Yeah, I mean, it's like,
Just total.
I don't know. Want over total? Sure. Want over total. I don't know. That might not be the best words for it, but that's okay. What are we doing?
Tastes like monkey.
We're putting these here. We're gonna steal your
It
rhythm.
tastes like apple.
That's why it tastes
Okay.
like monkey.
Want over total. And this is,
Get out of here.
I don't need those.
Good for you. Congratulations.
and so like for the example above, we had 525 divided by 10. So our mu is 52.5. Yeah, yeah. Mu is 52.5. Okay, standard deviation is the
We're it.
square root of mu, so the square root of 52.5. And that is something, I don't know, 7 point something.
Yeah, probably like that.
7.25.
7.25. Okay. All right. The variance,
It's mu.
oh, actually, I should say standard deviation is equal to this guy. Variance is equal to this guy, which is the square of 7.25, which if you square it again, you probably won't get exactly 52.5, but take the full decimal. Okay, so these guys are samesies. The mean and the variance are the same. Yeah, yeah?
I got him.
Okay, really quick. Let's find what is low and high. What is considered a low number of tornadoes for the year? What's considered a high number of tornadoes for the year? How do we do that?
Average plus 2 standard deviation.
Yeah, I take the average, which is my middle number, 52.5, and I add the standard deviation twice. Plus 7.25 plus 7.25. What is it?
67.
I think that's about dead. If we subtract
Jack is working hard to keep it alive.
14.5, it would be like 38. I don't know.
Something like that.
Is that right? Yeah, 38. So anything lower than 38 tornadoes for the year is a low year. Anything higher than 67 is a high year. Yeah, does that make sense? Do we understand where that comes from?
No.
Less than 38, higher than 65 or 67.
Hey, that's a naughty.
Good?
Forgot about this.
Beautiful?
That's the Monday.
We like it. We like it a lot. We like it a lot. Does it help to have it all condensed on one sheet? All of your information sucked into your brain? Okay. All right. Chapter 5. Not that. This one.
Yeah.
Chapter 5.
If we
Leave it
start
open to mind
from
The bottom?
end of it,
You want to start from the end?
yeah, because that's the stuff
Sure, I
we've
don't
been
care.
doing.
That's fine. 15. A tennis player makes a successful first serve 51% of the time. If she serves 9 times, what is the probability she gets exactly 3 successful serves? What is this? Is this Poisson? Is this binomial? What is this?
Racist.
What are they giving us? 51% is a percentage, right? So 0.51, what's that referring to? Like what variable do we put for that? She serves 9 times. What's the chances of making exactly 3? What?
Is that P?
That's P, I think. If she serves 9 times, so do we have a Q then?
Like that.
0.4.
Something or other.
0.49?
Yeah.
Okay, what's 9?
N.
N, that's a total number of serves. And 3 is
R.
R. So this is looking like binomial. Binomial. The part where it says assume that each serve is independent of others is basically saying she's not more likely to miss a serve if she served the first one before that in the net or whatever, like sometimes volleyball is a head game, So they're saying you're not taking that into consideration. So ignore that last sentence. All right, so we're doing binomial. N, P, R,
NC.
NCR. NCR, P to the R, Q to the N minus R. All right, let's set it up. 9, C3 times P to the what power?
3.
R,
Third
3.
times 0.49 to the
6.
6th. And we're just doing that one, right? Exactly
154.
3.154 or 15.4%. So if she serves 9 serves, she's about a 50-50 server, right? Half the time she makes, half the time she misses, which is not great. Serving 9 times, she will make exactly 3 of them 15% of the time. That sounds about right. What's the chances that she'll make all 9?
Very low.
Really low because she's only a 50-50 server, right? Does that make sense?
Slim pickings
Okay.
over here.
Slim pickings over here. 14. Find the standard deviation.
Why are we going backwards?
I don't know. Find the standard deviation for the binomial distribution. We have 3 ways of finding standard deviation. We have a standard deviation for 5.1, 5.2, 5.3. Which one is this?
5-2.
5.2 because they give me N and P, right? Okay, so standard deviation for 5.2, look at your formula sheet. 5.2 across says the square root of NPQ. Is that true? That's for standard deviation. Yeah? So the square root of N they give me is 48. P, they say is 3/5. I don't like that.
0.6.
0.6. What's Q then? 0.4. Okay. What does that come out to be?
3.39.
3.39. That's my standard deviation. Okay? Use your yellow sheet. Figure out like what information you're given, which standard deviation am I trying to find. Yeah? Good? Okay? 13. The probability that a call received by a certain switchboard will be wrong is 0.2. Use the Poisson distribution to approximate the probability that among 150 calls. Okay, I'm going to stop. Poisson is mu and x. Those are the 2 things that I need. Mu is the mean. X is the number that I want. Okay? So assume that, or approximate the probability that among 150 calls received by the switchboard, there are at least 2 wrong numbers. This one's hard. At least 2 wrong numbers. So my X is 2 or 3 or 4 or 5 or 6 or 7 or I have no idea, all the way up through 150.
Let's not do that.
Bruh.
Wait, did we just do
Hint. Find P of 0 or 1 and subtract.
True.
Right? True? So instead of doing 2 and 3 and 5 and 6 and 7, I'm going to go 0 and 1. Those are going to be my X's, but I have to do Poisson twice. Okay, what is the average number of wrong ones?
0.02.
Nope. 0.02 is the percent that's wrong. 2% are wrong. So how many will be wrong?
Divide 1.
2% of 150.
3.
Yeah. 2% of 150 is saying there should be 3 wrong calls out of 150. Okay, what's the chance that I have 0 wrong calls and 1 wrong call? Okay. If 3 wrong calls are out of 150, what's the chances of me having none wrong calls? What's the chances of having 0? I think high because 0 and 3 are close to each other, right? That's going to be a lot lower than like having 10 wrong calls, right? Yeah, does that make sense? 1 is going to be closer to 3, so that's going to even be higher. All right, so the first, P of 0. And the next one, P of 1. Okay, my Poisson distribution has this guy. We're gonna do both of those, and we're going to add them together, and we're going to subtract. Okay, so I do mu, which was 3, to the 0 power times e to the negative third all over 0 factorial. The second one is 3 to the first power times e to the negative third all over 1 factorial. Do you know what 0 factorial is? 1. Do you know what 1 factorial is? You make that make sense.
I don't.
Math.
I don't know.
Something like that.
So the 0 is
Always remember
zero
to try
point
and
zero
do
four nine eight.
Okay.
math. Let's do math.
The other one should be a little higher than that. Because 1's closer to 3 than 0 is. Do you all know how to type this in?
Yes.
Remington's doing all our
149.
point 149?
Yeah.
Okay. All right, if I add those together, that is like about, I don't know, 0.19, I don't know. What is it? What?
1.
8, carry the 1, point 0.199, 0.1988.
1988.
Yeah, so about 19, almost 20%, right? Okay, that's the chances of 0 and 1. What's the probability of having 2 or more?
Lower
Subtract it from the
than, so
100.
like
100% minus that would be 80%,
80.12.
80.12. There's an 80% chance I'm going to have 2 or more mixed calls or 2 or more wrong calls. We hope that this is not like to dispatch. It doesn't say what type of switchboard I guess it is. I don't know. I think like 911 operates off of a switchboard.
Dude.
Doesn't
what
it?
the hell happened to my sweater?
Like when you call into 911. Let's hope that none of them are wrong. I don't know.
Aren't you an EMT?
What? Yeah.
Aren't you an EMT?
Yeah. So like when you call into 911, it should automatically ping the closest dispatch. And then dispatch will then dispatch out. So it does happen wrong because like sometimes we'll get dispatched to like calls that are actually in Blue Hills District, but I think they do that on purpose.
That's what happens with my dad.
Yeah. Like we get called out to like people that are I won't say who, people that are really close to like they're in Blue Hills District, but like we get called to them because they know that like Blue Hill only has like 3 EMTs and they only like, and then nobody's going to be around during the day, so that's why we get called. So I don't think that happened by mistake. This is asking for mistakes. I don't think that happens by mistake. I think they purposely called us to come out.
Where's the nearest dispatch?
So ours gets dispatched out of Nelson. Then there's one from Clay Center that you dispatches. I can't talk today.
Doesn't Blue Hills get dispatched out of Clay Center?
Yeah, they don't get dispatched out of us. Yeah, out of Nelson.
Who knows that?
Nelson's is Superior, Nelson, Hardy, Ruskin, and us. Those 5.
And then Blue Hill and Red Cloud and Air.
I don't know. I don't know who they have.
Clay Center.
I don't know who they have.
Or maybe Air's out of Hastings.
Yeah, probably.
I think
because
Air's
they're
probably
Adamstown.
out of Hastings.
Yeah.
Because it's Hastings Rural is what it's called, yeah.
Yeah.
So is it
I
just
don't know.
Blue Hill and Red Cloud?
Glenville gets dispatched out of somebody, but I don't know.
Probably Clay Center.
You think so? Maybe. I don't know. Or maybe somewhere south, like,
But I know Blue Hill
like,
gets dispatched out of
I don't know.
11 first.
Yeah, let's do 11 first. Suppose that the weight of adolescence is being studied by health organizations and the accompanying tables are the probability distributions for 3 randomly selected adolescents. And we're talking morbidly obese. Okay, so let's talk about this table. We have 3 people in a room. The chances that none of them are morbidly obese is 11%. The chances that 2 out of the 3 are morbidly obese is 45%.
Kind of high.
It's America.
Still. For
That sounds like a lot. The chances that all 3 of them are morbidly obese is 22%. So none of those things are rare to happen. If you walked into a room and you had three adolescent kids and all 3 of them are morbidly obese, that's not a rare occurrence. Right? 22% of the time.
Morbidly obese means like death.
No, not really.
Yeah, that's what morbidly means.
Well, yes, morbidly obese means
Die from being fat.
right. But like morbidly obese, like the cutoff for morbidly obese, like
It's based off BMI.
Yeah.
It's based off your BMI. Sometimes like athletes that are like really muscular, like when they go to the doctor, they're considered morbidly obese, and they're like, how does that work?
Kids aren't going to be muscular. They're morbidly obese.
But you're an adolescent.
But it doesn't make sense for it to
That's like
Yeah.
I'm not really muscular.
Well,
either.
like Jack's an adolescent. I don't know. Maybe Jack's 18 by now. I don't know. So like, Kellen's an adolescent, and he probably would go to the doctor, and they would tell him he's obese. Like, I'm serious. Like, they would probably tell you that you're obese just because you're tall and you're muscular. So you would probably fit into the obese category,
Thanks.
even though it's stupid. Like, that's dumb. Like, what?
The schedule is
That's
really
not,
messed
oh,
up
it's not even this.
for Friday. Look at 4th and 5th period.
Like an hour
Oh,
long.
And then the
And
other
then
one is like
some.
negative minutes.
not that bad.
What?
Can I go to the bathroom?
No.
Look at 4th and 5th.
Oh, because that says 11:54 and not
10:50.
10:54. It should say 10:54 and 10:54. Those are just supposed to be 10s.
56 and then 11:38.
Yeah, those are just supposed to be 10s. Shoot, I'm gonna have to fix my schedule. I don't know. Okay, all right, here we go. Is it significant? Okay, here we go. Is it significant to have no obese subjects? Is 0 a significant number? No, 11% chance of having none. 11.1% chance. Not significant. And every time I see the word significant, I think rare. It is not rare for 0 of them, for none of them to be obese. Okay, that was kind of easy. Find the standard deviation. Boo. Okay, this is the gross part. Okay, when we do this is the icky part. When we do this, we have to find the average first. We have to find the mean. All right, this is the icky part. We have to find the mean. Finding the mean. How do you find the average of this table? You multiply them across. X times P of X, and then you add them together, right? 0 times that is 0. 1 times that is 0.215. 2 times that is 0.9. 3 times that is 0.6. No, 672. Add them together. I can't do that in my head. This guy's formula is X minus mu squared times P of X. What?
1.787.
1.787?
I think.
Does that look like that would be the average? Right? Like if I'm looking here, it's going to get pulled closer to this 0.45, so it's going to be closer to 2 than it is to 1. Right? So 1.787 sounds about right? Yeah. Okay. All right. Now, this is the icky part. I have to do this guy. I have to sum them. That's going to give me the variance. You have this written on your sheet. And then I have to take this square root. Is going to be the standard deviation.
What?
Okay? All right, this is my formula. All right, so I'm going to write the formula out. X, what's my first X? 0 minus 1.787
That's not
squared times 0.111. Then I have 1 minus 1.787 squared times 0.215. Then I have, are you writing this down?
No.
You should. 2 minus 1.787 squared times 0.45. Then you have 3, the last one, minus 1.787 squared times 0.224. Ooh. Okay, stop. Write this down. 26.
Which one are you doing?
All of them.
All right. Thanks, Ram. Let me know when you're ready for me. What? You what?
Hold on.
You want me to do some?
No.
You want Jace to do some?
No.
I've already done them.
Okay.
0.354,
0.354,
0.133,
0.133,
0.02,
0.02,
0.33.
0.33. Okay. The sum of all those is, I don't know, 0.8 something. This is a 7. 6, 7, 8, 3, 1, 837. I was almost there. Okay, standard deviation. Square root of 0.837. And that is 0.915. There you go. Finally. Those are the yucky ones. Yicky. No, no.
Can Jace go to the bathroom now?
Can Jace wait like a little bit?
Wait, go down again.
Let's see if we can do 2 more and then we'll be done. What?
You got 37.
At 0.837. I was about ready to add. Yeah. 0.837.
Oh, it's nice to show up now.
Happy New Year.
He must have been real sick yesterday.
What?
He had to go home and make his whatever he made. What did you make?
Remember? Because you wanted stuffing.
Yeah. Did you make it?
Love stuffing.
You didn't make it.
How do you know that? It's in
'Cause-
the box.
Okay.
I can follow directions.
All right. Sure. Okay. Ready? 10. Let's try to get these done. Assume that the procedure yields a binomial distribution. Oh, look at that. That tells me where I'm at. Which section are we in? 5-2. With a trial repeated 30 times. Use the binomial probability formula to find the number of successes to be 5. They call it X. We call it R. The probability of success is 1/5. I don't like that.
I don't like it either.
0.2. Q is 0.8. All right, let's set it up. This is easy. We've done this one already, I think. 30. C. 5.2 to the 5.8 to the nope 25. There you go. That's all. What? 0.172. Is that a rare event to happen? Nope. Because if my probability of success is 0.2, 5 out of 30 actually ends up being 1/6, which is 0.167, which is close to 0.2. Yeah? But it's actually 0.16 repeating. Does that make sense? You see the method of my madness, right? Like 5 over 30 is pretty close to 0.2 to begin with. All right, last one. In a Gallup poll of randomly selected adults, 66 said that they worried about identity theft. For a group of this many adults, find the mean number who do not worry about identity theft.
So do we just take that times
Bro,
0.34?
What are you getting those?
Yeah. 66 worry about identity theft. The people who don't worry about identity theft would be 34%, and we want 34% of the 1013, which is like
344.42.
344.42.
12 temple.
I don't care, that's fine.
Now making 254.
Good? Do we see why that is? 0.34 times that? Good? All right.
Yeah, you just wait till I get this, buddy.
Beautiful. Okay, done. We'll do the front side on
260.
Monday, and then we'll see what we're going to do from there. I don't even know. Okay, goodbye.